Let's try to use our knowledge of the geometric series to find a power series representation of the function f of x equals 2x over 1 plus x. We're also going to try to figure out where the power series converges and where its sum actually matches this function. As in the previous example, we have, by substitution, 1 over 1 plus x is 1 over 1 minus x. Substituting minus x in the power series expansion of 1 over 1 minus x, we get 1 over 1 plus x is the sum from 0 to infinity of minus x to the n. This works for every value of x for which minus 1 is less than minus x, which is less than 1. The sum from 0 to infinity of minus 1 to the n, x to the n, is equal to 1 over 1 plus x for x values between minus 1 and 1. Now we're actually interested in the function 2x over 1 plus x, and since 2x over 1 plus x is 2x times 1 over 1 plus x, we have that f of x is 2x times the sum of this power series, which is 2x times 1 minus 2x times x plus 2x times x squared, etc., etc. And multiplying the 2x by every term, we get that this is equal to the sum from 0 to infinity of minus 1 to the n times 2 times x to the n plus 1. So we now have a power series expression for the function 2x over 1 plus x, and that is the sum from 0 to infinity of minus 1 to the n times 2x to the n plus 1. And we know that this holds for values of x between minus 1 and 1. And we can actually also figure out that the interval of convergence of this power series is from minus 1 to 1, and if I plug in minus 1 or 1 there, you'll see that the series diverges by the divergence test. So actually minus 1 to 1 is the domain of this power series, and it coincides with the function 2x over 1 plus x on that domain, the interval from minus 1 to 1.